All right, welcome to today's explainer. So imagine a high-tech detective case. The clues are petabytes of telemetry data, and the clock is absolutely ticking. Today, we're going to learn how to slash your mean time to mitigate, or MTTM, using Grafana Play. We'll do this by doing something incredibly powerful, structurally correlating your Loki logs and Prometheus metrics right there on the exact same dashboard. Let's get into it.
Picture this. It's 2 a.m. Your pager goes off. Payment processing latency just spiked massively, and the business is literally losing money by the second. Can you find the root cause in under 3 minutes? Well, for most teams, the answer is unfortunately a hard no. Solving a mystery this fast, it requires way more than just having good data. It requires having the right tools working seamlessly together.
And this right here brilliantly illustrates the core issue. On the left side, we've got the old way, isolated panels. You spot a metric spike in one tool, and then you're frantically switching tabs to manually hunt for logs in another. It's kind of like finding fingerprints in one building and the murder weapon all the way across town. But on the right, that's structural correlation. By leveraging shared labels between your metrics and logs, you can pull off sub-minute root cause analysis.
So moving into section 1, the isolated data problem. Why context switching kills incident response times.
You see, the biggest enemy of an SRE detective is losing context. As we scale up and ingest petabytes of data daily, the absolute critical metric for your team is mean time to mitigate, or MTTM. But here's the thing. Your MTTM is heavily degraded when you have to manually pivot between disconnected systems. Every single time you switch a screen, copy a timestamp, or retype a query, you're losing precious seconds, and honestly, your cognitive focus. Seamless pivoting is what actually drives down that MTTM.
Which brings us to section 2, unifying metrics and logs, building the ultimate case board.
The secret sauce here lies in the fundamental design of Loki. From day one, it was architected to be quote-unquote Prometheus for logs. It organizes your log data into streams defined by labels. Think job, instance, and service. Because they share this identical DNA, a metric spike detected in Prometheus maps directly to a log stream in Loki with the exact same metadata. There's no guessing involved. That structural correlation is already built right in.
So how do we actually build this? In a modern dashboard layout, we use a super simple 3-step architecture. First, you drop your Prometheus time series panel right at the top. This acts as your entry point, your global health check. Second, you place a Loki logs panel directly below it. And third, this is absolutely key. You pre-filter those logs using shared template variables. If you're following along in Grafana Play, you'll see it in action. When that top metric graph spikes, you literally just look down to see the immediate log evidence waiting right beneath it.
Okay, section 3, configuring dynamic data links, connecting the clues dynamically. Enter the correlations editor. This lets you define permanent, context-aware links. You simply map a source field, like a hostname, using a variable syntax like the one shown here. Then you set your target data source to Loki, and the target query automatically injects that hostname straight into the logql. You're literally turning your metrics into clickable buttons that hunt down the matching logs for you. It's a total game changer. And that brings us to variable orchestration. When you set up a data link on a Prometheus panel, you can use an orchestration URL. Notice how that variable perfectly preserves the time range? That keeps the exact time window of your metric spike locked in. You don't have to manually re-enter timestamps or service filters. One click, and boom, you're transported to the logs for the exact millisecond the anomaly occurred. Moving right along to section 4, split view correlation, interrogating the evidence side by side. For those deep dive investigations, we jump into Grafana's Explore mode. Here's the exact 4-step procedural workflow you'd use. 1. Click Explore from the panel menu on your metric spike. 2. Click Split to duplicate the environment into a side-by-side view. 3. In that new pane, select Loki and run a logql query using your shared labels. And 4. Enable time sync. I have to say, this feature is absolutely brilliant. When you link those time pickers, both panels navigate the timeline in perfect unison. If you click on a specific sub-second interval in your Prometheus graph on the left, your Loki log panel on the right automatically scrolls to the identical timestamp. It literally acts as your automated detective assistant, making sure you're always looking at the exact right clues at the exact right time.
Let's see it in action. Section 5, Case Study Payment Processing, the 3-minute resolution.
All right, let's put all these tools to the ultimate test with a real-world support scenario. Here is our incident response timeline. Minute 0, we get hit with an alert for a massive latency spike in payment processing. Minute 1, we click the spike on our dashboard, which instantly auto-filters the logs. Minute 2, we jump into Explore Split View and run our log QL. Minute 3, we find the root cause and close the case. Let's walk through exactly how this happens. We start with our initial suspect. Our Prometheus dashboard is showing a massive spike in API gateway errors. Traffic goes from perfectly normal, blasts past the warning threshold, and slams straight into a huge block of HTTP 429 rate limit errors. Now, because we have our data links configured, the on-call engineer just clicks directly on this anomaly. Clicking that spike automatically carries all our context over and executes this specific logql query. It instantly cross-references the exact moment of failure. Zero typing required. This system already knows exactly what service is failing and at what exact millisecond the metrics went totally crazy. And there it is, the smoking gun, right there in the Loki logs. The error message clearly reads supplier rate limit 429, coming from the Fresh Foods Wholesale API. Our external supplier had started rate limiting our requests. By structurally connecting that Prometheus metric spike to the Loki logs, the automated correlation walked us right to the confession. Case closed. So the crucial takeaway here is that number 3, this entire root cause analysis, from the very first pager alert to isolating the exact external API failure, was completely wrapped up in under 3 minutes. By keeping metrics and logs on the exact same dashboard and linking them dynamically, you absolutely slash your standard MTTM. Which leaves us with this final thought. Are your telemetry signals still acting like isolated clues scattered across different tools? Or are they working together to automatically solve the case? If you want to stop the endless context switching and start solving your incidents in literally minutes, it might be time to upgrade your observability architecture. Turn those standard dashboards into connected case boards. Thanks so much for joining me on this explainer, and happy sleuthing.